In this last video for our Chapter 6 test review, we'll cover number 11 and number 12. So in these problems, these are all about comparing side lengths and angle lengths. And so remember, when we do this, we're interested in comparing the angles or the sides that are opposite the sides or the angles that we're looking at. So for example, in our first problem here for number 11, we need to compare the length of AC to the length of DF with either less than, greater than, or equal to symbol. So first, let's find these two sides. So AC is here, and DF is here. I don't know the lengths of these sides, but I do know the angles that are opposite them. So I can compare the angles that they are opposite to in order to compare the side lengths. We're using the hinge theorem here to do this. So AC is across from the 115 degree angle. And DF is across from the 110 degree angle. While 115 is greater than 110, so that must mean the length of AC, whatever it happens to be, is greater than the length of DF. And our second one here, angle HGI, that is this angle here. I'm going to shade it in blue. And angle IGJ is here. So we need to look at the sides this time that they are opposite to. Angle HGI is opposite side HI, which has a length of 6. And angle IGJ is opposite side IJ, which has a length of 6. And 6 is equal to 6. And so what that means is the measure of angle HGI, whatever that happens to be, must also be equal to the measure of angle IGJ. This picture, we're comparing some side lengths. So KL is this side here. It is opposite the 19 degree angle. Side MN is here. It is opposite the 35 degree angle. 19 is less than 35, which means the length of KL is less than the length of MN. In this picture, we're comparing the length of JH, which is here, to the length of JG, which is here. So in this one, even though I've got two different triangles, I'm actually just comparing the lengths in this triangle on the top. So I could completely, if I wanted to, completely ignore this bottom triangle here. So this is an example where we're comparing side lengths that are part of the same triangle. So remember, to do this, I need to look at the angles they are opposite to. JH is opposite angle JGH, which is 70 degrees. And segment JG is opposite 75 degrees. Well, 70 is less than 75. So whatever the length of JH is, it must be less than the length of JG. And our final problem, number 12, write and solve an inequality for the possible values of x. So this is similar to what we just did. We're going to be comparing some angles here to help us figure out what are the possible values that x could be. So first I want to find, okay, where is x? X is in this angle here. And so what I need to do is I need to compare these two angles. So to do that, I'm going to look at the sides that are opposite them. Okay. The 3x minus 9 degree angle is opposite side AC, which has a length of 9. The 36-degree angle is opposite AD, which has a length of 12. So if I was comparing these two angles, what I know is that 3x minus 9, this is the smaller angle. And the 36-degree angle is the larger angle. This helps me set up an inequality. So in order for this situation to be true, first, my smaller angle, 3x minus 9, that has to be greater than 0 degrees. Otherwise, it wouldn't be an angle. So 3x minus 9, since it's the shorter side, it has to be greater than 0 degrees. But it also has to be less than 36 degrees, because 36 degrees is larger than 3x minus 9 degrees. So I also know that 3x minus 9 degrees has to be less than 36. So I've got two inequalities here that I have to solve. I'm going to get x by itself. I'm going to add 9 to both sides. Divide both sides by 3. This tells me that x has to be greater than 3. When I solve this inequality, I'm going to add 9 to both sides. Divide both sides by 3. And this tells me that x also has to be less than 15. So x has to be greater than 3 and less than 15. This is one of those compound inequalities I have to put together. So x has to be greater than 3 and less than 15. If it falls anywhere within that range, this is a situation that's possible. So my final answer is this compound inequality.